Lesson 5.1, we're going to look at writing two-step equations. The focus in this lesson is just on writing the equations, not solving them. We'll be learning later in the chapter how to actually solve the equations. So it starts on page 253. We're going to go ahead and skip over to 254. So on example 1, what equation can be used to represent the numbers of golf balls in Marley's and Tucker's collections? So you can see Marley's collection with no information given, and then you see Tucker's collection is 159 golf balls, and we know that Tucker has 3 more than twice Marley's golf ball collection. So what we could do, one option would be we could make a bar diagram. Tucker's collection's 159 golf balls, and that's if M is Marley's, we can see that's 2 times as much plus 3 more. That's kind of how they're getting that bar diagram. You don't have to do the bar diagram. If it helps you though, go ahead for it. And then they made an equation off of that. So they said 159 is equal to 2m plus 3. Now, before they got that equation, they kind of just made a general statement. So they said Tucker's collection is equal to twice Marley's collection plus, and I would add in the number 3 there maybe, plus 3 more golf balls. So 159 then equals twice Marley's collection is 2m, and then 3 more would be the plus 3. When you write this equation, understand if we switch this around, that would be an equivalent equation. 2m plus 3 equals 159. That would be an equation that works also. That would probably be how I would tend to write the equation. Either one is fine. Obviously, they're the same as each other. Some people I've seen just really like having the variable on the left side rather than the right side. They just really don't like the variable being on the right side. So if that bothers you and you want to write it this other way, then you're welcome to do it that way as well. So if you look at the try it, Cole buys a new laptop for $335. He makes a down payment of $50 and pays the rest in 6 equal monthly payments P. What equation represents the relationship between the cost of the laptop and Cole's payments? So one thing in this problem, just to make sure everybody understands, is the idea of a down payment. So a down payment is basically if you're in a situation and you can't afford to pay for the full product that you're buying, then you can make a down payment, which is paying part of the cost, and then you can go back later and make other monthly payments in order to get it paid off. 2 very common uses of this would be for buying a house, obviously. People usually can't just say, well, here's $200,000 that I had just lying in the bank. Or buying a car would be another, probably the second most common use of that. In this case, somebody's buying a laptop, okay? Maybe somebody's buying a TV, they're buying a stove. Those are things they have, places, rental places that actually, some of them is like, rent to own, where you can, if you rent it long enough, then you actually own it at that point. Disadvantage is you're paying more money than what it would cost if you just bought it outright. But if you don't have enough money to buy it all at once, you don't have that kind of cash sitting around, then this is your other option. Okay, it's not just like, well, I don't have that much money, so I just can't get it. It's going to probably cost you a little bit more, but you can just gradually pay it off. And again, they just charge you a little bit more money by doing it this way. So if we look at this, we can just make a general statement here. Well, first of all, if you want to look at the bar diagram, the cost of the laptop, they told us, was $335. And the monthly payments, you can see they're making the 6 equal monthly payments, P. And then besides that, they did their down payment of $50. So the bar diagram may be a good visual for you of what's happening on this problem. And then next we can look at what they're doing down below. So the cost is equal to, we could say the cost is equal to the down payment plus the number of payments times the monthly payment. So in other words, how many payments did we make times how much did we pay each time that we made a payment. Okay, so this just gives us a framework that we can start with. Might help us to come up with our equation in the next step. So to start out with, the cost they told us was $335. The down payment was $50. They made 6 payments. I'm not sure why the book's using the multiplication symbol. We kind of went away from that, so maybe just parentheses there. And their monthly payment, we don't know, but they're telling us monthly payment is P for payment. So, obviously, if we're doing these problems, if we knew everything, it wouldn't be a very interesting problem. So they're going to generally give you one thing that you're trying to find, one variable in these problems. And then the next line, you might say, why do they have another line here? The next line, they're just kind of saying we could condense that slightly. 50 plus 6p. 6p still means 6 times p. And you could have it switched around. That's the same as 6p plus 50. Or, technically, our whole equation could be switched around. And like I said, it's kind of a idea of what do you like to work with. This last way that I wrote this is kind of how I like to work with the problems. If I have a choice, I'm going to probably write it like that, with the variable on the left side first thing, and then the rest of the equation after that. But technically, any of those 3 options, those are all equivalent equations. And understand at this point, they are not asking us to solve and figure out how much the payments are. They're just asking us to write the equation. So we write the equation and we're done for right now. Example 2, a baseball weighs 25.75 ounces less than a bat. Write an equation that represents the relationship between the weights of a baseball and a bat in terms of the weight of the box W. So if you look at the picture off to the side here, there's some other information. So we have a box that contains 50 bats and it weighs W ounces. And then they also told us that one baseball weighs 5.25 ounces. So kind of like we did on the last problem, we could start with just a general statement here. So we could say the weight of the baseball is 25.75 ounces less than a bat. So we could say weight of the baseball equals the weight of the bat. I would probably just go ahead and say minus 25.75. We can probably figure that part out to begin with. And then from there, it's just substituting. So weight of a baseball, we know weight of the baseball is 5.25 ounces. The weight of the bat, this is a little bit different because actually we don't know, and we're not even using just a variable for the weight of the bat. We're using W for the weight of this whole box. This whole box has 50 bats in it. So how would we figure out the weight of one bat then? Well, we'd take the total weight of the box and divide it by 50, right? Okay, now we're not being technical here. Obviously the box itself has some weight to it, so we're just not getting into that technicality, making things a little simpler than what it actually is. But so the weight of one bat, we would take the weight of the box divided by 50. Okay, that's how they got the W divided by 50 there. And then minus the 2575. So that would be an equation that we could use in order to figure out the weight of one bat. Okay. Sometimes I have people that kind of think in a different way a little bit than this. So, a different way of thinking about it might be, well, we have the weight of the baseball, and they kind of sometimes people work backwards in thinking about this. They say the baseball weighs 5.25 ounces, and then that's 25.75 ounces less than the bat, so we do plus 25.75, and then if we take that times 50, that would tell me the weight of my box. Okay, and again, that's just kind of a different way of thinking about it. For some of you, that might make more sense than what we did the first time. Some of you might think that's, I have no idea what you just did there. Okay, hopefully, one way or the other, if you're able to relate with one of those two methods to work these problems out. So if we look at the try it, Marcia and Tamara are running a race. Marcia has run 4 kilometers. Tamara has completed 3/4 of the race and is 2.5 kilometers ahead of Marcia. Write an equation that represents the relationship between the distances each girl has run, and let K represent the total length of the race in kilometers. On a problem like this, I would recommend that you draw a picture or diagram of kind of what's happening. So one thing we could think about to start out with is that for our race, we have a start and a finish. And the first thing they told us, Marcia has run 4 kilometers. Since Tamara is not done with the race, we're going to assume Tamara ran more than Marcia. We're going to assume Marcia has not finished the race either. Now, 4 kilometers, I don't know exactly how much that is, how much of the race that is. It could be less than half, could be half, it could be more than half. I don't really know, but it's some part of the race that Marcia's ran, okay? She went from the start until some distance, and she's ran 4 kilometers. Okay? Tamara, if we look at her, it says she's 2.5 kilometers ahead of Marcia. So we know she has run more than Marcia. And it says she's completed 3/4 of a race. So I've got an idea of maybe how far that is. Okay? This may not be exactly perfect, but it's just an idea to give me a basis for how to work this problem out. Okay, so Tamara has completed 3/4 of the race and is 2.5 kilometers ahead of Marcia. So a couple things here. One thing, Tamara's completed 3/4 of the race. K is the total length of the race, so we could say Tamara, this distance, even though it may not mean anything to you at this point, the distance she's gone is 3/4 times K, 3/4 of the total race. And the other thing we know is that She went 2.5 kilometers more than Marcia. So this little part here would be 2.5 kilometers. So if you'll notice on this diagram that we've drawn, we have these two pieces here add up to being the same as the distance that Tamara's gone. So we could say 4 plus 2.5 equals 3/4 K. The km is standing for kilometers on the first part. We don't really need to put that in our equation. Just understanding when we get our answer would be in kilometers. You could obviously switch that around. 3/4 K equals 4 plus 2.5. Another way you could do this, you could say something like 4 equals 3/4 K minus 2.5. So in other words, just a different perspective. Again, this would be probably how I would tend to think of an equation for this problem. Example 3, Claire bought 8 tickets for a total cost of $104. She had used a coupon code to get $3 off each ticket. Let X be the original cost of each ticket. Which of the following equations correctly represents the situation? All right, so if we look at these different options, this first option, if X is the original cost, if we do X minus 8, that's like saying we got $8 off, and then the times 3 means we bought 3 tickets. That's like 3 tickets, $8 off of each ticket. That's not what we want. The second option is a little bit better maybe. 8X, that's like 8 tickets, regular price, and then we got $3 off. Well, it doesn't say that. It says that we're getting, the coupon is $3 off of each ticket, not just, what's our total cost, and then we just save $3 off of that. So that doesn't work. One more chance here. So the last option they give us, the X minus 3, that's $3 off for a ticket, and then times 8. So we figure out, the X minus 3, that's the cost we're paying for one ticket. We take that times 8, and then that gives us a total cost of $104. So that is the correct equation for what's happening on that problem. So if we look at the try it, at the mall, Claire buys a hat that is 60% off, and socks that are reduced to $5.49. And she spends a total of $9.49. So if X represents the cost of the hat, which of the following equations correctly represents Claire's shopping trip? So on this problem, we're actually looking at how much she's paying. So the hat was 60% off. Full price is 100%. 60% off means she's paying 40%. The original cost of the hat was X, so that would be 0.40X if we put that to a decimal, or that's the same as just 0.4X. That's what she's paying for the hat. The socks, she's paying $5.49. She's spending a total of $9.49. So that matches up with the second equation that they've given us here. So the key concept just kind of talks about some different situations we might have when we're setting up our equations.